Greetings students. In this module, what we are going to do is area of a triangle and Heron's formulae. So, what is area of a triangle? We have to show that with the usual notations. Area of a triangle ABC is given by half into BC sin A, which is equal to half into CA sin B, and which is also equal to half into AB sin C. So, in triangle ABC, if we have opposite sides as C, B and A respectively, in that case, if angle C is an acute angle. Also, you have another triangle ABC. Opposite sides are C, A and B respectively, where angle C is an obtuse angle. You also have triangle ABC such that its angle is an right angle. Opposite sides are C, A and B respectively. In all these cases, let perpendicular to each triangle be AD. So, in all these triangles, we are drawing perpendicular, which is nothing but AD, and that AD be H. H is the height. So, moving ahead, we know that area of a triangle ABC is what? Half into base into height. So, it is half into BC into AD. So, you know that angle C is an acute angle. If angle C is an acute angle, we can say AD upon B is equal to sin C. Because ADC is a right angle triangle. So, we can also say AD is equal to B sin C. But AD is nothing but height. So, it would be H is equal to B sin C. Similarly, angle C is obtuse. In this triangle ADC, we know that AD upon AC is equal to sine of pi minus C. You know the linear pair axiom. If angle C is obtuse and the remaining part of C would be pi minus C. So, we know sine of pi minus theta is sine theta. So, AD by AC would be sine C. We also know that AD upon B, it is already from the diagram that the side is B. So, it would be AD upon B is sine C. Therefore, you would get AD is equal to B sin C, but AD is height. So, it would be H is equal to B into sin C. Moving ahead, if a triangle is a right angle, we know angle C is a right angle triangle. In this case, AD upon AC would be equal to 1. Why is 1? Since it is sine of pi by 2. We also know that AD upon AC is equal to sin C. So, if AD upon B is equal to sin C, where AD is the height and it is represented by H, so I can say AD is equal to B sin C and AD is replaced by H. So, H is equal to B into sin C. Now, in this case, in all these cases, if you have observed, H is nothing but B sin C. So, we can say that area of a triangle ABC is nothing but half into BC into AD, and which is equal to half into A into H. Yes, but H is what? B into sin C. Therefore, I can say area of a triangle ABC is half into A into B sin C, which is equal to half AB sin C. So, I can also say that similarly, area of triangle ABC would be half into BC sin A, and it would also be equal to half into CA sin B. Moving ahead, Heron's formula. We already know that if ABC are the lengths of the sides of triangle like BC, CA and AB of triangle ABC, and A plus B plus C is given by 2S, then area of a triangle ABC is given by root of S into S minus A, S minus B, S minus C. Moving ahead with its proof, it says what? Area of triangle ABC is what? Half into AB sin C. We all are aware about this. But we also know that sin cos theta is 2 sin theta cos theta. So in this case, equation would be half AB into 2 sin C by 2 into cos of C by 2. We know that the 2 and 2 are getting cancelled. Also, area of triangle ABC is equal to now AB into sine of C by 2 can be replaced with root of S minus A, S minus B upon AB, and cos of C by 2 would be replaced with root of S into S minus C upon AB. In this case, if you observe, AB is common. So, out of the square root, you would get AB square. So, AB square root is AB. So, AB and AB would get cancelled. So, what you have in the square root term is area of triangle ABC is equal to root of S into S minus A, S minus B, S minus C. So, students, make sure that all these important derivations you do it well. See you in the next module. Till then, keep studying. Thank you.